we will learn how to create functions in Swift. We'll also go over the importance of abstraction. So let's start. To create a function in Swift, we have to use func, and then for this task, we have to create a function called introduce myself. So func introduce myself, and then we use parentheses, and then we use curly brackets. So this is the basic syntax of creating a function. And now we just have to create a print statement that gives a quick introduction of ourselves. So print, and then double quotes, I love programming in Swift and love making mobile apps. I also like playing chess. So now let's see what happens when we call our function. So to call the function, we just type the name of the function. So introduce myself, and then there should be parentheses after it, just like how we initialized it. So now we can see that it prints what we wrote inside the function. And functions essentially help us make our code more efficient and allow us to run in nonlinear time. So let's go over to the next task. Write a function called magic 8-ball. So we'll write a function, and we're going to write func, and then the name of the function, and then parentheses, and then curly brackets. So this function has to use if or else statements to create a custom response based on the number generated, and we'll create a constant named random, and it will be equal to a random integer between 0 and 4. And now, depending on what random is, so if, let's say, if random is equal to 4, then we would print, let's say, it is 4. And else if random is equal to 3, we can print same thing, but it is 3. So now we can use this for all other cases. And one more time, I believe. Okay, so now if it's 2, we do that. If it's 1, we do that. And if it's 0, we use that. And let's say it's 3, it is 2, it is 1, and it is 0. So let's now call a function and see what happens. Magic 8-ball. Okay, so it seems, so we have to use double equation marks to show, to test if it's equal or not. And okay, so we got 3 this time. Let's run it again. We got 2, we got 4. So it works. So in this case, we're calling the function in the same way we call the function here, and there are no parameters. But let's see what happens in the case when there are parameters. So our next task would be using functions that are key. Okay, so we have to we're creating a function for a fitness tracking app, and it looks like we have to create a function called increment steps, and after declaration steps, below it'll increment the steps by 1, and then print its value. Call the function multiple times and observe the printouts. So first, let's create the function. So it's func, and then func, and then we're going to type the name of our function, parentheses, curly brackets, and now we're going to see it's going to write a function, and it will increment the steps by 1. So to increment it, we do steps plus equal to 1. So that increments the value of steps by 1. And let's print the value of steps. So let's print steps. And let's call the function to see what happens. So let's do increment steps. So we got 1. And okay, so now after the print, and it'll increment the steps by 1, and then it's print its value. So each time is equal to 1, and then we'll do that. So after the declaration step below, call the function. So when we update it, we get 1 because every time it reruns the whole code, and we're declaring it as 0 before we do this. So increment steps by 1, and then print the value, and call the function multiple times, and observe the printouts. Similarly, if you want to regularly provide progress updates to a user, we can control flow statements to check on progress into a function. So our function will be called progress update. So func progress update, and curly brackets. And then the functions print you're off to a good start if steps is less than 10% of the goal. Okay, so if steps is less than 10% of the goal, so 10% of the goal is, I believe that's 10,000 divided by 10. So if it's less than 10%, then we print you're off to a good start. Now, let's say if it's less than half of the goal, so else if steps is less than, this time, 10,000 divided by 50, so if it's less than half of the goal, or less than 2 divided by 2, so if it's less than half of the goal, we'll print you're over halfway there. And now if it's less than 90% of the goal, so else if steps is less than 90% of the goal, which is 10,000 times 0.90, so that's 90%, then we could do you're almost there. Okay, so then we could just essentially initialize this as 9,000. And for here, we could do the same thing. We could use the goal and goal. And now if it's and if it's beat your goal otherwise, so else print you beat your goal. Okay, so let's run and see. Now we have to call the function. So progress update. So you're off to a good start. So if number of steps is less than goal divided by 10, print you're off to a good start, and our steps are less than 11 hour steps, so essentially 1. Let's go to the next exercise. So in this exercise, we have to create a new function called introduction. So func introduction, and it should take 2 string parameters, name and home. So now we're getting to parameters. So parameters are essentially ways to I guess, customize or make your function do stuff based on certain inputs. So the syntax of a parameter is, let's say we have the parameter name, so we type name and then the type, so it's a string. We use a comma if it's multiple, so next one is home, and then we use a colon and the type, so string. That's the same thing. And before we just had parentheses, now inside the parentheses we declare the parameters. And then, and another parameter called int. So we do another comma, and then this time it should be called age, and then int. Function should print a brief introduction, i.e. Mary, California 32, or passing function. I print Mary 32 is from California. Call the function and observe the printout. So this time let's do print, and let's say we need to print first the name. So we do name, and we use the same variable we declared here. So name, and plus let's actually add a comma and a space. And now we're going to add that's another way to do it. We could essentially put all of this inside double quotes, and now we could say using escape, we could use the parentheses and then type the name, so the variable name, and then we could act like it's part of the string, and now comma space, and then again backslash parentheses age and then comma is from, and backslash parentheses location home. Let's call our function in production. And for the string, I'll say, so for the name, I'm gonna make one up. I'll say Jack. And then for the string, we could say New York, and then int 25. Now we can see that it prints Jack. 25 is from New York. Now we're going to write another function. So func named called almost addition. And this time it takes two integer arguments. So parentheses, the first argument should not require an argument label. The function should add two arguments together and subtract 2. So here we'll get into argument labels. Here we'll get into argument labels. Essentially, argument labels are something you add before the parameter name. Let's see an example. So here we need two integers. We can name this int 1, or we'll just say 1. And then the argument label is essentially the external parameter name. So it could be called 1 outside. And then now the internal parameter name could be number 1. And we could next we say the type, so it's an int, comma, so another one, so we could say 2, and then number 2. And now we'll initialize the type for this one too. And then the function should add the two arguments together, subtract 2, and print the result. So now we're going to use curly brackets, and then we have to add the two arguments together. So we're going to print number 1 plus number, let me also use number here, number 2. And so we're going to first add these two numbers together, and then we're going to subtract 2, and now we're printing the result. And let's call the function, so almost addition. And the first one would be, let's say we do 10, and then we could say 30. So here we can see it adds the two numbers and then subtracts 2. So argument labels are, for example, 1 in this case, and it's like an external parameter, and you can use that when you need like an external parameter and then like a different internal parameter, so it's easier to maintain, keep track of what variables you're using, and it's helpful in some cases to be more readable for the user. So the first argument should not require an argument label. So we can remove an argument label. So we can remove 1 here, and then remove 2 here. So now it's just like before, but here we would need to say 1, and now we could just do almost addition, and we could do number 1 and number 2. So in this case, the first argument should not require an argument label. So we do not want to say number 1 every time it calls it. To do that, we would use an underscore before it and space. Now we can remove the argument label, and when we call this, it won't require an argument label. So it still performs, so the function still works correctly, and we haven't provided an argument label. That's because we added the underscore. Next, we write a function called multiply. So function multiply, and it takes 2 double arguments. So we could say, so the function should multiply 2 arguments and print. The first argument should not require a label. The second should have an external label. So since it should not require a label, we put an underscore, and then we can name this double 1. And then the type would be double. Next, it has to have an external label by. So we could say by, and this time double 2, and the type is a double. So let's use curly brackets, and the function should multiply the 2 arguments and print the result. So we'll print double 1 times double 2. Now, the reason the argument labels are differing is because the first one we use the underscore, so we don't have to say double 1, and so we just name it. We could say 3.5. For the second one, it has a argument label, and it's called by. It's the external label, so we would have to say by, and the value of double could be something like 4.7. And now it multiplies the 2 numbers together. So next, we would have to create a similar function to what we did before regarding progress update, but this time we're giving it 2 parameters. a type int for steps and a type int for goals. Let's see how we would do that. So first, let's create the function. Control Z. So first, let's create the function, and it's going to be called progress update. And now we would need to have it. We would need it to have two parameters. The first one is a type int called steps. So we say steps, and we initialize the type int, and comma for another parameter, and this is called goal, and this is also int. And this function, like before, should print you're off to a good start if steps is less than 10%, and so on. And we can actually reuse the same code from our initial function. So if we'll copy that part, and now we'll paste it here. But there are some differences. So for example, it takes in the goal, and steps is the same variable, and but the goal here could be different. So here we would have to do goal and divided by. So if steps is less than 90% of the goal, so that would be around divided by 9, or it divided by 10, and then times 9. Or I could do goal times 9 divided by 10. That would be 90% of goal. And it's func. Okay. So let's run our code and see what happens. Yes, we also have to call the function. So let's do progress update. And then number of steps, we could say 6,000 as an example. Our goal could be 10,000 steps. So we should essentially be over halfway there. Let's see what it says. Should run. Oh, okay, we don't have a print statement here. We figured that out. Okay. Great. Okay. So we can remove this for now. Let's continue. So your fitness tracking app is going to help runners stay on pace to reach their goals. Write a function called pacing that takes 4 double arguments called these stuff, and then your function should calculate whether or not the user is on pace to hit the goal, beat goal time. If yes, print keep it up. Otherwise, you gotta push it just a bit harder. So let's create a function. We'll name it func, and then specify what we should name it. Didn't say what we should name it. And so let's say pacer. We can name it pacer, and it should take in 4 doubles. So let's call the first one current distance. So current distance is a double. Goal distance is a double, and then current time is also a double. Goal time is also a double. Okay, and your function should calculate whether or not the user is on pace to hit or beat goal time. So to do that, we would essentially have to figure out what pace they should be, and then if they're on, whether they're on or above the pace or below the pace. So we would print. So firstly, if they're on, the pace is equal to or greater than the pace they should be on. So to calculate that the pace they should be on, it would be total distance divided by goal. So total distance, fitness by a function that takes 4 arguments. So current distance, and then total distance, and then current time, and then goal time. Okay. So the total distance is, let's say, 5 miles, and then the goal time would be in 5 minutes. And that's not realistic, but 5 minutes, so easy to math. And if the current distance is 3, essentially the ratio should be greater. So we can do total. We can do if total distance divided by goal time is greater than current distance. Let's see what happens. Current distance divided by current time, and we also need to make it equal to. So we could do greater than or equal to or greater than. And now we would need to I think it goes after. Okay, so we would need to print your keep it up. So we print keep it up, or else you've got to push it a bit harder. So I just realized I've switched this, so this actually should go here, and that actually should go here. And the logic behind that is that essentially that we are calculating what the current pace is, so the current distance divided by current time, and we're checking if their current pace is greater than or equal to the pace they should be. So let's call this function pacer, and let's give an example. So we could say there are 5 miles, and the total is they're at 5, I guess, minutes. 5 miles, and then okay, I realize I named these two things the same thing. This should be total. Should be current distance, total distance. So current distance could be, total distance could be 10, current distance 5, current time could be 6 minutes, total goal time would be 10 minutes. So they should be on their pace. And we would have to print these. Okay. Okay, you gotta push a bit harder. So the current distance is so see they're below, they're overtime. So we should do 4. That's good. They're on time. So yeah, this one is very interesting, and I believe we have covered most of the basics here. Let's go into a bit more examples. So we have to write a function called greeting, and it's called greeting, and that takes in a string argument called name. So name type is string, and then it returns a string that greets the name that was passed in the function, i.e. if you pass in Dan, it return the value might be Dan. How I use function with the result. This is fairly simple, so we could do print backslash parentheses. Actually, before that, we would actually do hi, and then parentheses. Okay, and then we would write name. So hi name, the comma after the hi, and then we could say how are you. Now let's do greeting John. This is say hi John, how are you? Okay, there's extra double quote there. Hi John, how are you? So it works. Now write another function that takes in 2 integer arguments, and so the function multiply 2 arguments, add 2, and then return the result. Use the function and print the result. So we could do function. Essentially, it should return the result. So we should have this as a return, and then we would need to print what we would get. It should essentially be the same thing, unless unexpected non-void return value in void function. Okay, so I guess it could be based off that way. Oh, so since we have it as a non-void, so as a void function, it shouldn't have a return. Okay, so function, and now we're going to call it, I guess, multiply add 2, and we're going to say num1, it's an integer, num2 is an integer, and now we're multiplying 2 numbers, so we're going to print num1 times num2, and then we're going to add 2 to the result. Now let's call our function multiply add, would have 9 and then 10, so it should be around 92, and print the result. Okay, let's go on to our next exercise. So for this exercise, we would need to write a function that only does a portion of what a previous pacing function did. This function we call calculate pace, and should take 3 double arguments: current distance, total distance, current time, and it should return a double that will represent the time at which the user will finish, run based on the user's current distance and current time. Call the function and print the return value. Okay, so the function should be called calculate pace. It essentially calculates the time, taken 3 double values, so this is one value, and it'll take another double value. It'll take in another one called current time. And now we are going to calculate the user's pace. So firstly, let's just say let pace is a constant. We're gonna let pace equals current time divided by let's do current distance. So let's say it's 5 miles, and then current time. So it'll give us a ratio, and it's a 1-to-1. So let's say if they ran 10 miles and it took them 20 minutes, it'll give us 1/2. So basically every 1 mile it would take them 2 minutes. And now it will represent the time at which the user will finish the run based on the user's current distance and time. So we'll take total distance. So this is the rate at which they're traveling. So we're just going to take total distance and we're going to print the value. So let's assume now they're at 20, we would divide the total distance by the rate at which they're going. So we could print total distance divided by the pace. Now let's call our function. Calculate pace. Let's give examples. Current distance, let's say they ran 5 miles, total distance is 10 miles, the current time is 10 minutes, so it should take them double times 20 minutes. Okay, that seems to be working. Now I have a function called pacing that takes 4 double arguments. The function also return a string that will message the user. And okay, I believe this is essentially the same thing we did over here. Let's okay, but they said name it this time, so we'll name it. So pacing. Taking 4 double arguments like before, called current distance, total distance, current time, goal time. The function will also return a string, which will be the message to show the user. The function should call calculate pace. Function should call calculate pace. So it should call calculate pace. So to do that, I guess pass in the appropriate values and capture the return value. The function should then be compared to the return value to goal time, and then if the user's on pace, keep up, and return we got to push a bit harder, otherwise call okay. Okay, so to be able to return specific values rather than print statements, we would need to use a, I guess, line and then a greater than sign, and then the type it will return. So this one will return a double. Now we could just say, instead of print statements, return the value of that, and we're going to print what we get. So it should work the same way, and we should get 20. Great, okay. And now we would need to, we're going to call calculate pace. So let's see, let's call calculate pace over here. Calculate pace, and the current distance will be current distance, double will be total, it will be total distance, current time will be current time. And if that's greater than, okay, so this will also return a double. And now, so if that's their pace, so it gives us the time that they will take, that they're projected to finish. So if the time that they're projected to finish is less than or equal to their goal time, and if it's less than or equal to goal time, then it should be keep it up, or else we would have to call, else we're going to return, you just got to push a bit harder. So let's return this. Okay. And missing return, okay, so cannot convert return type of string to double, so the return type here would actually be a string. Let's see what it returns, and let's print what we get as it returns. we can keep it up. That's good. And we'll do the same thing. So use the function and print the result. And the return value might be, so we're going to return. So we're going to return the string value. And now we're going to print the value. And now we do the same thing, but this time it returns an integer. And now we could do return that integer, and we'll print what it returns. It seems, okay, we still have the leftover parentheses. Okay, yep, that seems to be working. I believe it takes some time for these errors to go away. Okay, let's go over here too. And then if yes, print, otherwise you got push hard. So I think we're still printing here. And then call the function and observe the printout. So we're still printing. Let's see if we're still printing here. Call the function and the function observe the printout. So okay, so we're start returning from now. And where are the two errors? So they are here. Okay, expected expression. Okay, so it seems errors are gone. We can close the side panel. And that's it for this exercise. And to recap, we have learned how to create functions, what are argument labels, and how to utilize parameters. Check out the full playlist for the full Swift course. In this video, we'll be going over loops in the Swift programming language, specifically two main types of loops, a for each loop and a while loop. So let's get started. So first, let's cover the basic syntax of a loop. And in Swift, we do for, and let's create a variable called index, and let's loop through for index and 1 to, let's say, 100. Then we use a curly bracket, and then we do print our index. Let's run our code, save anyway. And nice, so we got all numbers from 1 to 100. What this is basically doing is it's setting index to a value in the range 1 to 100, and it's printing that index. So for every, just like it sounds, for every number, it prints that number. Let's go into more in-depth details now. Our first exercise is creating a for in loop that loops the values 1 to 100 and then prints each of the values. So similar to what we did earlier, let's do for index in 1 to 200. So this is essentially a range, and we use 3 dots to show that. There's curly brackets for a for loop, and we print index. Confirm it's working. Good. Now we can also create a for in loop that loops through characters in a string or elements in an array. So in this case, we have to loop through each of the characters in the alphabet string below and print each of the values alongside the index. So in this specific case, we can use the enumerated method. It's fairly simple. So let's first start with our for loop syntax. So for letter and alphabet, let's print letter. Now let's see how it goes. Good, so we're getting the letter, but we also needed the index alongside the letter. And to do that, we can do alphabet dot enumerated. What that does, it gives the letter, but also the index. But it returns it as a tuple, as you can see here. So tuple essentially is, think of it like a fixed array with only fixed array, and this time it has 2 values. So since it has 2 values, the first one is, let's go back. So the first one is the index. So we can do index, comma, letter. Now let's print the same thing. So let's print index, comma, letter. And great. So now we have exactly as we need with the index and then the letter. Next, we have to create a string dictionary where the keys are the names of states and the values are their capitals. Include at least 3 key value pairs in your collection, then use a for in loop to iterate over the pairs and print out their keys and values in a sentence. So first let's create our string dictionaries. So var Let's name this state, capitals. And let's set this equal to the state. So we can name this New York. And the capital is Albany. If you're not sure how to create a dictionary, watch my earlier video about Swift collections. So next, let's do California. And we'll set this equal to Sacramento. Next, do Texas. And this will be equal to Austin. Now we have to iterate through using a for in loop. So for, we can say, so we have to iterate over the pairs and print the keys and values. So to do that, we'll also get first a key. I'll get the value. So key value in state capitals will print. And first, let's print the state. So let's use escape sequence, and let's do our key. So that'll give us the state. If you're not sure about strings, there's also a tutorial about specific strings in Swift. And let's say New York is, actually let's do the value, so that gives us the capital. So, or we could do the key, let's say the capital, so the capital of the state is, now let's do value. Let's see what that gives us. The capital of Texas is Austin, the capital of California. So that's good. And we're printing, then we're using a for loop to print the keys and values in a sentence. Great. Let's continue. So suppose your app contains a list of different movements that can be tracked. You want to display each item in the list to the user. Use a for in loop through movements and movements below and print each movement. So it seems that we have to display each item in the list to the user. So what we can do is do for item and movements, and we'll just print movements, I believe, out. So we'll print item, and we get each of the items in the list. So I believe this is fairly simple. So we displayed each item in the list for the user, and we used a for in loop to loop through movements. Now suppose your app uses a dictionary to keep track of your average heart rate during each of the movements in movements. The keys correspond to the movements listed above, and values correspond to the average heart rate and your fitness tracker has monitored during a given movement. Loop through movement heart rates below, printing statements telling the user his or her average heart rate during each exercise. This is similar to what we did before. So for, we'll get a key and then a value in movements. Let's print. Let's say your heart rate is, and the heart rate is the value. So escape sequence and value. Your heart rate is a number during I guess as you and we'll say the key, so what their activity was. Let's see how it goes. So your key value per in movements. Okay, so here we get the value as an integer, so we have to convert it as a int. Oh, I see. So we did movements, but it's actually movement heart rate. Let's see if this fixes the error. Great. Let's continue. Now we have to create a while loop that simulates rolling a 6-sided dice repeatedly until 1 is rolled. After each roll, print the value. So we have to use int.random to generate a random number between 1 and 6. So let's first cover how to create a while loop. So let's first create a while loop. So we do while, and it has to be a condition. So the condition is a boolean, so something while true, while false. So we can see while, and then we'll do int. So we can actually say roll, and while roll is, and we have to see until 1 is rolled. So while roll is not equal to 1, so we don't get a 1. So basically, till we get a 1, we would have to set this equal to roll. So we generate a new random value. Okay, and then we'll also print the value. So let's print. So let's do, so after each roll, so we'll print roll. Let's see how it goes. So, okay, run it again. Okay, so we got lucky. And great. So it's basically rolling some random number of times, and it's updating roll each time it does that. And it's checking if it's not equal to 1. If it's equal to 1, then it doesn't do the while loop, so then it continues on. So next, we might want your fitness tracker to help runners track and improve their cadence. Running cadence is the number of steps a runner takes in a minute. To help with this, you decide to let the user input a cadence, after which your app will play a sound at each interval they use to take another step. For this exercise, you'll simulate a run test for the cadence feature of your app. Use a while loop to print take a step to the console 10 times. This is the console. Once you successfully printed take a step to the console 10 times, add the following code at the end of your while loop. Thread.sleep, okay, and then this will pause, we'll put pause between each iteration of the while loop so that the print statement should actually occur at the proper cadence. Okay, so for this exercise, we'll have to use a while loop. So while, and let's see, so we have to do this 10 times. So while test steps is less than 10, we will firstly print them to take a step. Take a step. And then we'll have to use this. So thread sleep timer.cadence. So since we can see it's doing it an infinite number of times, we have to add this, and this time it waits. But we also won't need to update test step. So first, so we have to add 1 to test step. So test steps is plus equal to 1. So now it should only run 10 times. Great. Next, we recreate the above cadence using a repeat while loop. To create a repeat while loop, we have to do repeat. And this is essentially the same thing what we did here, but the repeat is the condition or the action. So we do repeat and then our action, but we have a while at the bottom. So this is our condition. So here we do while, and then test steps is less than 10. So this repeat happens while that happens. So that should do it 10 times, and this should happen 10 times. Great. Here we have to create a for in loop that loops through the alphabet, and essentially it has to print every other letter or just the one with even indexes. To do that, we can do for, and then let's do letter in alphabet. So this is a normal for in loop, and here we have to have an if statement to check if, let's actually enumerate this. So we get the index, and here we get the index and the letter. So if the index is multiple of 2, I believe its dot is multiple of 2, then we print, I believe, the letter, and let's also print, I think the letter is enough. So let's see what happens. So we get everything from A, C, E, G. So it looks like it is skipping every letter and till Y. So that's great. And believe essentially we're just taking in, if the number is even, then we're printing it, or else it just continues on. Now we have to create a string dictionary where the keys are names of state and the values of capital. glue at least 3 key value pairs, one with them being your home state. Now, loop through this dictionary again, printing out the keys and values in a sentence. Add an if statement that will check if the current iteration is your home state. If it is, print, I found my home, and breaks out of the loop. So we can essentially use the same one over here, but we'll have to make some modifications. So let's do the 3 states, and then now let's say, for example, New York is our home state. We'll add an if statement, so we'll loop the dictionary, printing out the keys and values in a sentence, but add an if statement will check if the current iteration is your home state. If it is, print, I found my home, and break out of the loop. So let's actually do California, so we can get the first one and then break, so it doesn't go to Texas. Break is essentially a way to break out an inner loop, so we're in a looper condition, since we're having another inner if condition, so if the key is equal to California, and we can print, I found my home. And then we will break. So it does the first 2, and then it breaks. That's great, let's continue. Here, we have to decide if we want our users to be able to put in a heart energy range they would like to hit. And then we want the app to suggest movements where historically the user reached that heart range. The dictionary movement heart rates below contains keys corresponding to the movements the heart has tracked, and values corresponding to the average heart rate of the user that your fitness tracker has monitored historically during the given movement. So we'll loop through movement heart rates below, and if the heart rate doesn't fall between lower and higher average heart rate, continue to the next movement and heart rate. Otherwise, print, you could go, and then insert movement here. So let's essentially do a for key value. So we get the movement and the heart rate. In the dictionary movement heart rates, we will print curly brackets. So we have to check for condition. So if the value is greater than lower heart rate and value is less than a higher heart rate, we will print. And then this print statement they provided, the string. So we print, you could go here and let's make this a escape variable. So we'll print activity, which is the key. And let's see if it works. So you can go skiing, or you can go running and skiing. So now let's see if low heart rate, so walking is too low, running is good, swimming is too high, cycling is too high, skiing is good, and climbing is too high. So great, we completed this exercise. See you in the next one. Hello, in this video we will be covering collections in the Swift programming language. The 2 main collections we'll be going over are the Swift arrays and Swift dictionaries. First, let's cover the basic syntax to initialize those 2 collections. So let's create a variable named names, and to create an array, we would use square brackets. An array can hold multiple amounts of data, so it could hold multiple strings. So we can say John, Kate, Alice. So now we have 3 names in our names array, and we can print our names array, and we get our output. And dictionaries are pretty similar, but they have 2 different values for each of the values in a similar format. So basically, there's a key and then there's a value assigned to that key. So instead of a names array, let's create a grades dictionary. And to create a dictionary, we also use square brackets. But after we have a name, we use a colon. And let's say 97. So that indicates a grade. So this is the key and this is the value. And now let's do the same thing for the rest of the names. So we can say 95 and 96. And now we can print our grades dictionary. And we get our output.
So let's start learning these two collections with some examples. Our first example, we have to create a registration list that holds strings. And this list is for keeping track of who has registered for a community charity event. So firstly, we have to create a variable, so var, and then it's called registration list. And we can set that equal to an array that will hold strings. So we could use square brackets, and it should be empty after initialization. So this is an empty array. But since we want it to hold only strings, we can even directly put the type, so we can write strings right next to our initialize of our name. And this indicates that this is an explicit string type. Next, your friend Sarah is the first to register for the event. Add her name to registration list using the append method. Print the contents of the collection. So to append or add to a existing array, so let's append Sarah to the list by first calling our list, registration list, and we do dot append, and then we add the element we want to append. So we want to add Sarah. Now let's print our collection. So we can do print registration list. And see, now in our list we have Sarah. Now we have to add 4 additional names using the plus equals to operator. And all of the names should be added in one step, and then we print the collection. So to do this, it's pretty similar. We first set our registration list equal to plus equal. So this means we're adding to our registration list. And since it's an array or a list, we have to use square brackets. And let's add 4 additional names. So John, Mark, Lucy, and James. So now this will add these four items in the array to our original registration list array. Let's print the contents and see. Great. Next, we have to use the insert method to add Charlie into the array as the second element. So to do that, we do registration list, and just like append, we do dot and then insert. So for this, we first have to identify the element we're inserting. So we're adding Charlie, and now it will be inserted at, so we have to make it a second element, and the indexes of an array start at 0. So this is 0, 1, 2, and 3. So if you want to insert the second element, it should go right before mark. And to do that, we would use 0 if it's the first one, and 1 to say if it's the second one, 2 if it's the third one, and so on. So we do insert at 1. And now let's print our collection. Registration list. And it seems Charlie is added as the second element. So it seems somebody had a conflict and decided to transfer registration to someone else. So we have to use array subscripting to change the 6th element to Rebecca. So to do that, we would set registration list, and we have to access the 6th element. So since the indexes of an array start at 0, we would do the 5th element by using square brackets. So registration list, the 5th bracket is equal to, and now we're going to set it to Rebecca. Let's print our array. Let's see. Great, so it changed to Rebecca. Next, we have to use remove last on registration list. And then if correctly, this should remove Rebecca from the collection. Next, we store the result of remove last into a new constant deleted item, and then print deleted item. So to do that, we would first create a new constant called deleted item. So let is used to create a constant. Let deleted item is equal to, now we have to call remove last on registration list. So registration list dot remove last. And so if this is done correctly, it should remove Rebecca, and let's print our new constant. deleted item. And it looks like, oh, so we did remove first, you would have to do remove last. And then it should print our last item, which is Rebecca. Great. Let's continue. So now, it seems we have activity challenge. So let's say we have a fitness tracking app that shows users a list of possible challenges grouped by activity type. So walking challenges, running challenges, and etc. A challenge could be as simple as walk 3 miles a day or as intense as run 5 times a week. Using arrays of type string, create at least 2 lists, one for walking challenges and one for running challenges. Each should have 2 challenges and should be initialized using an array literal. Feel free to create more lists for different activities. First, let's create a walking challenges array. So let's do var walking challenges is equal to walk 5 miles a day as example. And we could also do walk 5 miles. We could do walk 20 miles in a week. And now, since each should have at least 2 challenges, that's complete. Let's do the same thing, but for running challenges. So var running challenges is equal to run 1 time a day. We also do run 7 times a week. Okay, so that seems to be good too. And next, we need to... Okay, so that's good. We have completed the first part. So in our app, we also want to show all of these lists on the same screen grouped into sections. Create a challenges array, so another array called challenges that holds each of the lists you have created. It will be an array of arrays. Using challenges, print the first element in the second list. So essentially, we're creating a 2D array. To create an array of array, we would first initialize our challenges array, and in that we would put in our individual walking and running arrays. So walking array, comma, running array. So this should include both of our lists or both of our arrays in one array. So here we can see that it works. And using challenges, we have to now print the first element of the second challenge list. To do that, we would do challenges, and we have to print the first element in the second challenge list. So second challenge list is at index 1, since it starts at 0. So index 1, and then now we get the first element, so we go to index 0 in the first element. Let's see, it's run 1 time a day. Let's go see. So this is our second challenge list, and the first element is run 1 time a day. All of the challenges will reset at the end of the month. Use the remove all to remove everything from challenges. Print challenges. To remove all, we would essentially just have to call challenges.remove all, and it removes everything from challenges. Let's print challenges to confirm. See, now challenges is empty. Next, we have to create a new array of type string that will represent challenges a user has committed to instead of available challenges. It can be an empty array or have few items in it. So let's create a new type array of type string. So to do that, we'll do var and let's name it committed challenges. Committed challenges. Let's set that equal to, we can set it equal to 1 challenge. So let's set it equal to run 1 time a day. You can say run once in a day. Next, we have to write an if statement that will use isEmpty to check if there's anything in the array. If there is not, print a statement asking the user to commit to a challenge. Add an else if statement that will print challenge you have chosen is, if the array count is exactly 1. Then add an else statement that will print you have chosen multiple challenges. To do this, let's create our first if statement, if, and let's check if committed challenges is empty. So if committed challenges dot is empty, and that will result a boolean true or false, then we would have to print please commit to a challenge. So we're asking the user to commit to a challenge. And else if to check the size of an array, we would do committed challenges dot count. So if it is equal to 1, then we can print challenge you have chosen is, and we could name this challenge you have chosen is chosen into a challenge. So to do that, we can do escape and then committed challenges .0 so we get the first challenge. Challenge you have chosen is run once in a day. Okay, so that seems good. And we write an else statement. So else, we will print you have chosen multiple challenges. And let's check our code. So we're writing an if statement to check if it is empty. And so if it is empty, then please commit to a challenge. Else if the count or number of challenges is equal to 1, then we print the challenge you have chosen is in the challenge. Else, we print you have chosen multiple challenges. Let's continue to our next exercise. So our next exercise is create a variable string int dictionary that can be used to look up number of days in a particular month. Use a dictionary literal to initialize it with January, February, and March. January contains 31 days, February 28, and March 7. Okay, so to do this, we'll first create a variable, so var, and we will name our dictionary, I guess we'll name it months, or number of days in month. Number of days in month. So then we'll set that equal to, so we can specify the type, but compiler should be able to infer it. So we can say string int, and we'll let that be equal to a dictionary. So we'll say January, which has 31 days, February, which has 28 days, March, which has 31 days. Our dictionary. So now we have to use the subscripting syntax to add April to the collection with a value of 30. Now let's print our dictionary. All we have to do is do number of days, and we'll try to index or get April, and if it isn't there, it will add it. So April is equal to 30. Let's print our dictionary. And it seems April is added to our dictionary. It's a leap year, so we'll update the number of days in February to 29 using the update value method. To do that, we will do number of days in month, and then dot update value. And so we'll update it to 29, and our key would be February. Let's print our dictionary. and it looks like February is updated to 29. Use if let syntax to retrieve the number of days under January. If the value is there, print January had 31 days, where 31 is the value retrieved from the dictionary. To do this, we would use if, and we would let the date equal number of days in months of January. And then, so if there is a date, then we would print January has, and then to escape, and we'll put the date days. So let's see, January has 31 days. So that's good. Given the following arrays, create a new string dictionary shapes array. So we'll create a new dictionary. So var shapes array, and should use the key shapes, and colors array should use key colors. Okay. Print the resulting dictionary. So it should be a new string dictionary. So we can initialize it with like that. And then it should use the key shapes. So so we would do, I believe shapes is the key. So shapes, and then the array is shapes array. We haven't defined shapes array yet, but I believe we would create one. So is equal to shapes array, and then colors is equal to colors array. Okay, so we don't have shape arrays and color arrays. Let's create them. So var shapes array is equal to, let's set it to an empty one. Okay. Oh, so it should be, yeah, array of strings. And we could do the same thing to colors array. Let's see if it goes away. Cannot find type strings in scope. Oh, so we need string. And now we print the resulting dictionary. So we print. Oh, okay. So actually, in this case, we would have to create a shapes array and a colors array. So we would have to remove that. So given the following arrays, create a new string dictionary. So this would be a string dictionary. And they're wanting us to use the key shapes, and colors array should use the key colors. So let's create shapes, colors. So with an array literal. So I believe we would also have to initialize it like that. And we would also need to have the empty array inside. Okay, so now we print the last element of colors array, accessing it through the dictionary you created. So we would use an let if syntax or the force unwrap operator to unwrap what is returned from the dictionary before you can access the element of an array. So let's add a few elements to our list. So we could do squares, triangles. And here, let's just do blue and pink. And now we will use a let if syntax to print the last element of the colors array. So let's last element. So from this we can access an element of the array. So let's do let if let's do last element equals colors array, and we want to get the last element, so we would do colors array and colors, and let's inside colors, so this will give us this list, and we have to get the last element, so first index, and let's see how it goes. Now we're going to print the last element is last element. Okay, so let's see how it goes. So we expect the parent. Okay, so we have to do if let last element is equal to colors array colors of 1, then must be unwrapped or referred to member subscript. Okay, so it seems that rather than accessing the first element from here, we can actually access it when we have last element. So we can do the first element right there. So now we get the last element of colors array. So last element is pink. Let's go to our next exercise. In the previous app exercise, you written code to help users with run pacing. You decide that you could use a dictionary to let users store different paces that they regularly run at, or do interval training with. Create a dictionary paces of type string double, and assign it to a dictionary label with easy, medium, and fast keys corresponding to values. Okay, and then these numbers must correspond to mile pace in minutes. Print the dictionary. So we do a dictionary of var paces of type string double, and we assign it to a dictionary literal with easy, so it will be 10 corresponding values of 10, medium, so 8.0. Since this is double, we have to do 8.0, and then fast. And we can do 6.0. This is the mile pace in minutes. Let's print our dictionary. Okay, let's add a new key value to dictionary. The key should be sprint. So we could do paces sprint is equal to 4.0, and print the dictionary. So let's print paces. And great, so now sprint is added. Imagine the user in question gets faster over time and decides to update his or her pacing on runs. Update the values of medium and fast to 7.5 and 5.8 respectively. Print the dictionary. So let's do paces of medium is equal to 7.5, and paces of fast is equal to 5.8. The dictionary. So let's print our dictionary. And it seems I misspelled here. Great, so medium and fast are both updated. Now imagine the user in question decides not to store sprint as one or his or her regular paces. Remove sprint from the dictionary and let's print it after. So to remove sprint, we would do paces braces brackets sprint, and we'll set it equal to nil. So that essentially removes sprint if it is there. And let's print cases. And you can see that sprint is removed. When the user chooses a pace, you may want the app to print a statement stating that will keep him or her on pace. Imagine a user chooses medium. Accessing the value from the dictionary, print the statement, okay, I'll keep you at a, and we would put our pace there. Okay, so let's print it. So print, and now we have to insert pace value here. So the user is choosing medium. So let's do an escape sequence in parentheses. Now we'll do paces, and we'll just access medium. Now let's see what it says. I'll keep you at optional 7.5. Okay, so we have to make this explicit. So to fix the error we're getting, it's essentially saying that there could be a value there or there couldn't, so it's optional. And to do that, we'll have to specify a default value in cases where it's not there. So since it has to be a double, let's make it 0.0. So it says, okay, I'll keep you at a 7.5 minute mile pace. Great. Thanks for watching, and see you in our next session.
Hello, in this video we'll be going over enumerations or enums in the Swift programming language. So firstly, in Xcode, let's cover the basic syntax and how to use them, and then we'll dive into more advanced use cases and examples with even optionals and other Swift stuff incorporated. So let's say we have a variable called month, and we initially set that to Jan. Now to the month changes, and we set that to February. Let's see, now I changed it to a lowercase f, and in our program we don't know how that may impact our execution, so that could cause us error. Or if I did feb and added space, that could still give us an error. So enums allow us a better way to store this data in a safer way and in a much more optimized way, since storing a string each time takes up a lot more memory. It's not as optimized as the enum could be. So let's do enum rather than months. Let's actually just do weekdays. And now what we do is that we do pace, and then we could say Monday, Tuesday. Okay, so I have these written so far. So basically, the enum weekdays could be in either the Monday case, the Wednesday case, or any of these. So now, if we print weekdays, see what we get. So we get nothing as of now, because we haven't essentially set the case for weekdays. So to do that, we could do var day is equal to weekdays dot Monday. Now let's print day in our code. Monday. So great. Now we can easily switch between them. So now we can say day equal to, all we have to do is just use dot and Tuesday. So this way is much more safer because we won't make any mistakes, and it's much more optimized because Swift stores them in a way that's similar to indexing or other methods rather than just directly storing the string. Let's dive into more advanced examples now. So let's create a suit enum. So let's do enum suit. It has 4 possible cases. So case, let's say clubs, spades, diamonds, and hearts. Now we have to imagine that we're being shown a card trick, and we have to draw a card and remember the suit. Okay. Create a variable instance of suit called card in hand. So a variable and card in hand, and assign it to the hearts case. So we'll do suit hearts. Print the instance, so print card in hand. Now we got hearts back. Now imagine that you have to put the card back that you drew and draw a different card. Update the variable to be a spade instead of a heart. So we'll do card in hand equals dot spades. Now imagine you're writing an app that will display a fun fortune, or something like you will soon find what you seek based on the cards drawn. Write a function called getFortune, so it's a function. It'll be getFortune, and that takes in a parameter of type suit, so it'll be a suit. And inside the body of the function, write a switch statement based on the value of card's suit. Write a different fortune for each suit value. Call the function a few times, passing in different values for card's suit each time. So a switch statement in Swift, if you haven't gone over them, make sure to check out the for loops video. But in the switch statement, you have a case. So let's say, I added the card suit here, so it'll switch for each card suit value. Let's do the case. Let's say if it's not spades, then we will print let's just use the same one at the top for now. And then let's do the same thing. So case hearts, and we'll do the similar thing for the rest. For the hearts, we'll do, let's see, what are the other spades, diamonds, and then clubs. Now we're going to print similar thing for each one. Let's print you will soon find success. You will soon be faced with a challenge with great reward. You will soon find great opportunity. Now let's call getFortune a few times. Let's say dot spades, and let's do it for each one. Control Z. So now let's do dot clubs, diamond, and dot hearts. Okay, so we have all of those printed out. Now we'll create a card struct below. So struct and card. It should have two properties, so it should basically be so var suit, it'll be type suit, and it'll be var value, and it'll be a type int. Okay, how many values can playing cards have? How many values can int be? Would it be safer to have an enum for the card's value as well? Inside the struct above, create an enum for value. It should have cases for ace, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. Change the type of value from int to value, initialize two card objects, and print the statement for each that details the card's values and suit. So basically, we would have to create a value struct. So let's first say value for that. So I think I did something. Okay, now let's create so inside the struct. Let's create a value enum. So enum capital V, so value. We'll have a case for all of these. And then now we change it to value. Initialize two card objects. So let's just say var card1 is equal to card. And we'll say the suit could be anything, so like heart. And the value also has to be enum, so we'll say ace. Dot ace. Let's do a similar thing, but let's call this card2. Let's make this club. Let's make that a 5. Great. Now let's actually print the value. So let's print the card is a Let's do card1 dot value is 5 and an escape, and then we'll also do card1 dot suit period. Now let's do the same thing for card2. Card2 dot value and card2 dot suit. Wonderful. So it seems we're getting an error. So type suit has no member heart. Is it hearts? Yep, it's hearts. So it has to be exactly, and that's the benefit. So we get exactly same thing of those options that we wanted. So that's the benefit of using an enum. That safety that we got right here. Great. Now let's continue. So here we have to create a swimming workout struct. So struct swimming workout. Now we're basically tracking swimming workouts, and it has the properties. So var for distance, and it should be of type double. So that'll be a double. Var time is also a type double, and stroke should be type string. Stroke is a type string. Okay, great. Now we have to allow stroke to be a type string isn't very type safe. Inside the swimming workout struct, create an enum called stroke that has freestyle, butterfly, and all the other strokes. Okay. So the enum, we have to call it stroke, and then so the case can be freestyle, butterfly, backstroke, and breaststroke. And now we're going to change the type of stroke from string to stroke. I'm going to create 2 instances of swimming workout objects. I'll just do var workout 1 is equal to swimming workout. The distance could be 100, time could be 100. Stroke, it has to be one of those, so freestyle. And let's do a similar thing for our second workout. So this time let's make 150, 180, and the stroke can be backstroke. Now imagine you want to log swimmers' workouts separately based on the swimming stroke. You might use arrays as static variables on swim workout for this. Add 4 static variables: freestyle workouts, butterfly workouts, and so all of those workouts to swimming workout above. Each should be of type swimming workout and should default to empty arrays. So we are going to create static variables. So var and then freestyle workout should be of type swimming workout and should be empty arrays. Right, and I believe this how we're supposed to initialize them, and then now we could just change the names. And then backstroke workouts, and then breaststroke workouts. Great. Now let's add an instance method to swimming workout called save that takes no parameters and has no return value. So let's run save. Let's add the instance method save. So let's create a function called save. It takes in no parameters and returns no parameters. And it appends self to the proper array. So we're going to write a switch statement. So inside save, we're going to do switch. And we're going to switch based on stroke. Now if the case is dot freestyle, should we do cases dot freestyle? Then we can okay, so it seems that we have to so freestyle, and we have to do self dot freestyle workouts dot end. Then we're just going to add our swimming workout, I believe. So first, let's, rather than calling stroke, let's call ourselves. So let's call swimming workout. And we will, so what we have to do actually is call this stroke. So we will do self.stroke. And then we can now call the cases for each. So let's fix this by adding all our cases. Great. Now we can just do self.freestyle workouts append. So we're adding our workout to it. Now we can do the same thing for the rest. So we'll add it to the correct one. Add it to the workouts. This is a butterfly workout. Great. Okay. And so when we try to append here, okay, so we were able to fix the issue by making this mutating. And then when we call self.stroke, we use each, so we use .freestyle to get each of the cases, and then we do freestyle.append self. So we put self in append. And then in the end, I call workout.save. So workout1 and workout2.save. Then we're printing workout1, then we're printing workout2. That's it for this lesson, and see you in the next one. Bye. Hello. In this tutorial, we'll be going over typecasting and type inspection in the Swift programming language. First, let's go over the basic syntax and then go into more advanced examples. Firstly, what is type? So type essentially defines what the data is. So is it an integer, a boolean, a string? There are multiple different types, and this would be considered a string. So in Swift, type is strongly typed. That means that you have to specify what it would be, and in some cases it infers, so this would be a string. In some cases though, there can be a non-specific type. So example, this would be a string. But let's say we want an array. So let's do an array, but we're going to have multiple types. So we could have a string, we could have an integer, a number, we could have a boolean, we could also have a float. So what would be the type of the greeting? Here, you can see that we get an error. And that's because the type isn't explicitly stated. We don't know what it would be. So in these type of circumstances, we have to explicitly state that it is a list, but of type any. So this dictates that this list will have any type. Now let's print our list. Here we can see. Another thing we can do is inspect the type. So if we take the first value, so greeting, and the first index or 0th index, it would be a string. So if the first element in the list is a string, then let's print is a string. So our code. And here it's printed, it is a string because the first value hi is a string. So this is the basics of typecasting and type inspection. Now let's go into more advanced examples, more use cases. So firstly, we have to create a collection of type any. So let's create another list. So var list1, and it has to be of type any. Now let's create a few doubles, integers, strings, and booleans. So let's do hello 789.3 true 7 false 5 87.3 0.4 and another true. Also have code 23, let's make that 17. Okay, so we have a pretty diverse list with lots of types. And now let's print our list. And it gets printed. So now we have to loop through the collection, and for each integer, we have to print the integer has a value of, and then followed by the value of the integer. And repeat the steps for double, strings, and booleans. To do this, first let's use a for loop. So for, let's say, item in list 1, let's first see what it is. So if item is of type string, and we can print, then we have to say the string has a value of, and we can this time use escape to embed the item. Let's do the same thing for other types. This time if it's an integer, if it's an int, then the integer has a value of what the integer is, and if it's a float, then the float has a value of the value, and then if it's a boolean, so we have all four, then we would print the boolean. And for the boolean, we would have to use bool, so we can remove that. Great, so now it prints each of the values of our list, and it tells us what type it is, and then the value. So now let's create another string of any dictionary. So this time we're creating a dictionary. So you can say var dict1, and then it will be of type, so it will be a string with any value. Okay, and now it has to be where the values are mixtures of doubles, integers, strings, and booleans. And we print the key value pairs within the collection. So let's create a similar thing to what we did before, like this, but then we'll just say 1. Okay, let's add the L here too. Now we could say 2. And I'll actually copy and paste this. Great, so now we have created our dictionary, and now let's print our key value pair. So let's print dictionary1, and it prints. Okay, now we have to create a variable called total of the type double set to 0. We loop through the dictionary and add the value of each integer and double to the variable's value. For each string value, add 1 to the total. For each boolean, add 2 to the total if the boolean is true, and subtract 3 if false. Print the total value. Okay, so first let's create a variable called total, and it will be of type double, and we'll set it to 0. Now let's loop through to for item in our dictionary1. Now similar to what we did over here, we'll have to see what type it is. So if it is a string, then we add 1 to the total. So we'll do total plus equals 1. And if it's an integer, we add the item. So total plus equals item. And if it's a float or a double, let's name this as a double actually. So we'll do double. Also, one more thing, since we get a key value pair when we iterate through the dictionary, we actually have to specify. So let's say rather than item this time, let's do key, and let's separate with a comma like it'll come value in dictionary 1. And now we'll just check if the value string, and if it is so, we'll add 1. If the value is an int, then we'll add value. And we can also change this to double, so I'll go over and make this a double. Change this to. And if it's a double, we have to add, so we'll do total plus equals double. Oh, and since it's type any, we have to convert it to an int. So this will be an integer, and this value will have to also be an integer value. Okay. If it's a boolean, we have to use an if check. So if value is true, we will do total plus equals 2. So we're adding 2, else, and we subtract 3. So total minus equals 3. Okay, now let's make sure our list has some boolean. Good. And we have to convert this to a double. Same thing with this. And we also have to make sure that this is a boolean. We'll convert this to a boolean. Okay, now let's run and see. So we cannot convert type any to argument expected type bool. Okay, so we would have to. So the way to fix these errors is to use a different syntax to check if value is int or not, because since it's type any, it could be an optional and we could receive a null value. But in this case, we know that these aren't nil, so we can use the if let if check. So let if, let's say this is a double. So let if double is equal to the value, and we'll see if it's an int. So if it's an int, then we'll do total plus double, and we're going to take the double value or double constant and add it here. And it's a if let. Do the same thing over here. If let, and we'll say double, change this to an int. And these are just the name of variables. So if let double and value is of type double, then we'll add the double. And here, if let the bool is as of type bool, then we'll convert boolean of the bool, and then we'll check. And so we can close this, and actually we can remove the conversion since we're already using the let if let, then that means that it is only going to work if it is a bool. And we're not really using the key too, so we can make an underscore. So now we have to print the value of total. we have 227.0. Okay. Now let's create a variable called total2 of type double. And we'll loop the collection again, adding up integers and doubles. For each string you come across during the loop, attempt to convert the string to a number and add the value to the total. Ignore booleans, print the total. So in this case, let's actually have a string. So let's do a similar thing here, and let's iterate through our first dictionary. This time we're not going to do anything with the booleans, and we're going to add up all integers and doubles like before. But for the strings, we're going to attempt to convert the string into a number and add that value to the total. So to do that, let's use the if let statement. So if let, and let's name this string, and then we're going to take the value, but let's try to convert it to a string. So if we can't convert it to a string, then we're going to add it to the total. First, let's check if the value is actually a string. So let's do if value is a string, then we'll have to convert it. So then we're going to do total equals the int value, so enter a number, so we could even do double of that value. And this will be an optional because we don't know if it would be an integer or not. So in a special case like this, let's make that a string. So instead, let's actually do another if let statement, because since it's optional, it could give us a null. So if let string as int, and now we're going to set that equal to our double value of the string that we're getting. Now we can add the total2 value, make the total2 string as an int. The total2, and I also added a 9 like a string so we can see if the total changes. It does, so that's great. Let's continue. So now we have a fitness tracking app that may allow users to track different kinds of workouts. When architecting the app, you may decide to have a workout base class from which other types of workout classes inherit. Below are 3 classes. Workout is the base class with time and distance property. Run and swim are subclasses that add more specific properties to the workout class. Also provided is a workouts array that represents the log of past workouts. You'll use these classes and the array for the exercises below. Okay, so you have to write a simple function called describe run. So func and then describe run running workout, and describe swim. So you have to write 2 functions that take the run object and the swim object. So we'll say run. Then we'll also have to do a describe swim function. And this one takes in the swim object. So neither should return values, and each function should print a description of the workout, including the runner's cadence or the swim stroke. Time is represented in seconds, distance is represented in meters, and cadence is represented in steps per minute. So let's just print, and then we can say the run's cadence is, and let's use the escape. And let's do run the cadence. And let's also say the time is, and then run.time. The distance is, and then we'll also do 4,000. This should print the cadence, the runtime, and the distance. So let's do distance. Run.distance. So we're actually using type here. We have to use the actual workout we get. So let's replace the run with running workout. And error went away. So let's do a similar thing, but with swim. And swim's actually a bit different. So let's write it out. So let's do print, and then the swim's stroke is, and then we'll do swimming workout dot stroke. The time is, the rest is similar. And we'll replace this with swimming workout. Okay, now let's loop through each of the workouts using typecasting call either describe run or describe swim on each. Now observe what is printed. So typecasting is essentially using the as and question mark or optional to see if it can be. So we'll do for workout in workouts. We will if it can, let's say if the swim can be a workout, so if the workout is a swim, if the workout is a swim, then we'll let swim equal to that workout, and then we'll call describe swim on that swim. And we'll do the same thing with the run. So the run can be described as a run type, then we'll call the same run over here. And this has to be a running workout. And this should also be a describe run. Okay, and great. So we have actually got all this data into the correct format here, and we're just describing the time, distance, and cadence. Also, to make it a bit more representative, so let's add seconds. So time is seconds, and then the distance is meters. Always good to be descriptive, and then we'll also do the cadence is in steps per minute. So is steps per minute. Anything that's specified as stroke? No. So okay. Great. We have completed this. See you in our next exercise. Hello. In this video, we're going to cover scope in the Swift programming language. So scope is essentially where a variable can be used. So the example would be in this function, print bottle count. We're going to create a variable bottle count is equal to 99, and we're going to print it. So when this is called, we will assume to get print 99. Then bottle count is equal to 99, so we will assume that it would print 99 twice. But here, we're getting an error. It says we cannot find bottle count in scope. And that's because this bottle count variable, you could think of it as only active in this range. That's the scope. It's a local variable. But if we initialize a bottle count outside, put that to 100, now it's a global scope. So now it will be 100. So we'll get 99 from this inside local scope, and we'll also get 100 from the bottle count global scope, since it's outside a function. And since this is inside these curly brackets, this bottle count is only accessible here. That's the basics of scope. Now let's dive into more advanced examples. So in this example, we're going to describe why the code doesn't generate a compiler error if you uncomment line 10, why it doesn't generate a compiler error. And we get an error. And the reason is because the foo again is inside this for loop this time. So we can say foo, we'll say the constant foo is in a for loop, so it has a local scope. That means it cannot be accessed outside the for loop. But in this case, when we uncomment it, it still works. So let's explain why it works. So the reason it works is because x, say variable x, the variable x is defined outside the for loop, so it has a global scope, so it can be accessed. It can be accessed outside the for loop. But same explanation here. But the constant foo is in a for loop is say defined. A for loop in a for, so it has a local scope. That means it cannot be accessed outside the for loop. Now we have a function called greeting below. Use the variable shadowing when unwrapping greeting. If greeting is successfully unwrapped, print a statement that uses the given greeting to greet the given name. So if it's successfully unwrapped to have the value hi there, and then the name is Sarah, then we print hi there, Sarah. Otherwise, use hello to print a statement greeting and greeting the given name. Call the function twice, once passing the value for greeting and once pass in nil. So let's call it. So we're going to use a, let's see, variable shadowing. So variable shadowing essentially is using the same thing. So let's use the guard. So variable shadowing is when we say greeting is equal to greeting. So there are two variables, and the thing with a guard though is that variable greeting has a scope outside the guard statement too. So it'll be else. So if greeting is not null, then we'll do the rest. If greeting is null, then we need to return a for printing. So we're going to print a, okay, let's actually assign it what? We're going to print hello and then the name. And if there is a greeting, then we can just print the actual greeting plus the name. And let's see, we forgot a closing parenthesis here. And also, so the guard doesn't have a return or exit to scope. So let's do a return here. Now let's call the function twice. So let's do greeting, and let's say good morning, and name it John. Let's do a similar thing, but now in addition to this, to actually make this have a comma, so we'll have escape sequence greeting, comma, and then another escape sequence. Good morning, John, and here we'll just do a nil. So we're passing it a nil. Basically, this should happen. Hello, John. Great. Now we're going to create a class called car. Classes are always capital. And it should have properties for make model. So let's do var make. I type string, string, and int. So string var model. We also type string, and then var year is a type int. Since this is a class, you'll need to write your own member-wise initializer. Use shadowing when naming parameters in your initializer. Basically, when we initialize it, we have to use shadowing to use the same names. So we'll do make, and it will take in a string, and we'll do model, and we'll do the year, which is an int. It'll make more sense when we actually do it, but now to initialize it, we're going to use self.make is equal to make. So, or what we're doing here is the make here and make here is the same name. So this is calling this make, and this is calling the self. And the reason we're using shadowing is so we can demonstrate the use of self. And self basically says that we're going to access our car's properties. Also, the same thing for the rest. So model is equal to model self dot year is equal to year. Now let's make sure everything is accurate. Okay. Let's continue. So now we have a user struct and 3 user instances. These will be used throughout the exercise, and we're going to simulate a competition in the fitness tracking app. Okay. The function below takes an array of user objects and returns the user object that has taken the most steps. The body of the function first declares a variable that is an optional user, then loops through all the users in the array. Inside each iteration of the loop, it will check if the top competitor has a value or not by unwrapping it. And if the top competitor doesn't have a value, then the current user in the iteration is assumed to have the highest score and is assigned to the top competitor. If the top competitor has a value, there is code to check whether the current user in this iteration has taken more steps, then that is assigned to the top competitor. Okay. At that point, the goal is to assign the user with the highest score to the top competitor. However, the code generates a compiler error due to improper variable shadowing. Top competitor has a narrower scope than it should if it's going to be reassigned. Fix the compiler error below and call getWinner, that's the name of a function, passing in the array of competitors. Print the name property and the return user object. So let's fix the compiler error first. So here we're seeing that top competitor is a let constant. So what's basically happening is that we're assigning this top competitor to basically this, but we want to access this most likely. So what happens if we do the self.top competitor? So we can't use top self because it's not a struct. What we can do is change the name. So we'll say, rather than the top competitor, we could say top or higher competitor. And we'll just do higher competitor here. So now it knows, okay, so we don't need to change it, we'll just do top here because it wants to access that. We'll change this to higher competitor. This should fix the issue because now this isn't referencing this anymore, it's actually referencing that. Now, let's call getWinners. GetWinners, and we're going to pass in an array of competitors, so I would assume the competitors array. Great. Now, we're going to print the name property of the return user. So let's just say var top is equal to that. Okay, and then we're gonna print top.name. Know that you fixed the function properly if the return name is active sitter. Okay, so it must be unwrapped, so what we can do is use if let. So if let that, then we'll add some parentheses. Okay, so we have to remove this var. Right, we have been returned active sitter. Write a member-wise initializer out inside the user struct above that uses variable shadowing for naming the parameters of the initializer. So let's create a member-wise initializer. I'm going to use variable shadowing, so we're going to need to use self. So we will do init, and this will be the first thing it takes in. This will be the second thing it takes in. Now we'll just use self name is equal to name, and we'll do self dot steps today is equal to steps today. Perfect. Now we can so above and use variable shadowing, so we have done that. Now write a failable initializer inside user struct above that takes parameters name and steps today as optional string and int. The initializer should return nil if either parameters are nil. Use variable shadowing when unwrapping the two parameters. So to do that, we will okay, so we have an error here, and I think we have to add the s here that we may have misspelled. Great. Now let's create a failable initializer. So init, and then it will be the same thing, but one major difference, which is the removal of the addition of a optional in our input parameters. String and int are optional. So it should return nil if either are nil. So are we using it's like we're just going to use optional binding. So if let's use guard let's say name is equal to name and steps today is equal to steps today. So we're going to return nil if either of those are nil. Oh, and yes, we have to set them equal to each other here. And if they're not, then we just okay, so then we're going to now just set self.name equal to name and self.steps today is equal to steps today. Oh, and we forgot our else here. Let's see if it fixes an issue. Oh yes, and the let here, since we're assigning two different, we're checking if these two different variables are optional or not. Okay, great. So we have fixed all the errors and we have completed this exercise. See you in our next exercise that will be dealing with enumeration. Bye. In this video, we'll be going over guard in the Swift programming language. So guard is essentially a better way to use if-else statements and allows us to check unwrap optionals a lot simpler. So let's go over an example. So let's create a function, divide, let's call it divide, and we'll take in the dividend, and it will also, so it will be a int, or else make that a double, and I'll take in the divisor which will also be a double. But we can't divide by 0, or else app will get an error. So we can use the if statement to check if the divisor is not 0, but there's a better way. So we can do guard. So basically, guard and divisor is not equal to 0.0. So if guard's just saying that if this is true, so if this is true and else, so if that's not true, then run what's here, run what's in here. We'll add another one here. So if this is not true, then we're going to run this. So if it's not true, let's just return. Well, let's actually print. Let's print error. And so basically, if it's guarding against this, and now we need to, now we can just normally divide. So now we can just print. Okay, so we have to return. So let's just return an error. Else, let's return dividend divided by the divisor. Dividend divided by divisor. So let's run our code and see. Dividend. Okay, and we also have to make our function to be able to give a string. And since it will be a string, we'll put this into a string, but then we can use an escape sequence. We'll remove that. Now let's do divide, and let's give it 30, and we'll do a 6. So let's print the value of that. And here we get a 5. Now let's run. Let's put 0 here and let's see what happens. And we get the error. Great. So now let's go into more advanced examples and a few more use cases, including the use with optionals. So our first exercise is that we have to create a function, func, and calculate area. So the function takes in 2 double parameters. So x, and it will be a double, and y, which will also be a double. And it's going to return an optional double. So we don't know if it could be a nil sometimes, so we don't know if we'll always get a value or not. Now we have to write a guard statement at the beginning of the function that verifies the parameter is greater than 0. So guard. So we're going to check guard. Let's do if x is greater than 0 and y is greater than 0. Let's do, so if it's not, then since we're guarding against that, we return a nil. So now let's calculate the area. So we're basically guarding against values that are not greater than 0, and we'll just return x times y. Let's call the function now with some positive numbers. Calculate area. And let's do 20 times 5. Now, since it's returning, let's print the value it returns. Great, it gives us 800, which is an optional value. Now let's this time do something with negatives. So negative 80 times negative 15. And we get a nil as expected. Now we have to create a function that adds 2 optional integers, adds parameters, and returns an optional integer. Okay, so let's create a function first called add. It takes 2 optional integers. So we'll just do int 1 and then so it takes in 2 optional integers. So we would do int and then int 2. Let's put a t here, and let's say int is optional. And it returns an optional integer too. So it returns another optional integer. And we choose one guard statement to unwrap both optional parameters and return nil in the guard body if one or both of the optionals don't have a value. If both parameters can be successfully unwrapped, then return their sum. So to unwrap using guard, we would do guard, and then we would do let, and let's let int 1 equal to int 1. Also let's actually rename this. Let's rename this as int 1 like that. Let's int 2 equals int 2. So else, like before, we will return a null, so nil, and this essentially unwraps both parameters. So they're unwrapped into int 1 and int 2, and now we have to add for the zoom and return their sum. Okay, so we would just return int 1 plus int 2. Okay, now let's call this and see what happens. Print the add of 5 and 3. Now next time, let's make one parameter nil. So, okay, so it seems we're getting an error. Okay, so this is not a capital I, this is a lowercase. Great, so we have the optional 8 from adding these two, and then the nil that we were expected to get. Now we have another task, so we're going to work with UIKit objects, and we need to unwrap optionals to handle user input. For example, the text field initialized below have text properties that are type string, optional. Write a function that, given the below code, called create user. So that's write a function called create user. It takes no parameters and returns the optional user int object. Write a guard statement at the beginning of the function to unwrap the values of each of the text fields property. Okay, so we could do guard let, and we'll do first name is equal to user dot first. So each of the text fields, text properties. Each. So we'll have to go to the text field. Okay, and then text property. So okay, and then return nil if values are successfully unwrapped after the guard statement. Okay. So let's try user dot first name. Does that seem to work? So we can't call user because we're not using it. So fields text properties. So I'm assuming we have to use these. So let's actually just call this here, and let's put that over here. This should work. Now let's do let, and we'll do a similar thing. And we actually don't need to use, or we could use let, and another one, since there are 3. And then else, we'll return the nil. So next one is last name. And then the last one would be age. And we'll get this from last name text field. And we'll get this from the age text field. So if none of them are nil, then we can successfully, we have unwrapped the values and create and return an instance of a user. So let's create an instance of a user. So we'll do say user is equal to user, and then so first name is equal to first name, last name is equal to last name, and age is equal to age. And let's return our user. Let's see how well this goes. Okay, so it seems that we are accessing, oh, we forgot to make it a variable. and see if there's any other errors. Okay, so we can even make this a let. Now let's unwrap the, now let's call the function you made above. So we're supposed to make this above technically. So now let's call the function you made above and capture the return value. So let's print create, so let's call create user. Now, and capture the return value, unwrap the user with standard optional binding, and print statement print. Okay, so say user is equal to create user, and now we can unwrap user using standard optional binding. So to use standard optional binding, let's first make this a variable, and let's make this a user optional type. So this should make it unwrapped, and now we will print we'll print each of its properties. So we'll print the first name, last name, etc. So we'll do user dot first name, and it automatically adds the question mark. We'll do last name too, age. So okay, and since it's optional, we would have to unwrap the unwrapped properties. So to solve the issue of getting optional, we can use an if let. So if let first name is equal to, and then user dot first name, then we can also have this in here. We can just print user first name. Let's do the same for the other two parameters. Set this as last name, and then age and user's age. Let's call this by using last name and age. So this should remove the optional, and it did. Let's continue. So now we're going to create a workout struct, and our context is that in the exercise on optionals, we created a failable initializer for a workout struct that would only initialize workout if the start time and end time are further apart than 10 seconds. We'll now create the same failable initializer, only with a guard statement to check that the start and end times aren't too close together. Create a workout struct that has the properties start time and end time of type double. Okay. So we'll check if they're within 10 seconds apart using guard statement. If they are, the initializer should fail. Otherwise, it should set the properties accordingly. So to create a failable initializer, first let's create our workout struct. And it has two properties, the start time. So var start time and an end time. Now we're going to create a failable initializer. So in it, question mark, so it's optional. And to initialize it, we would need the start time again, which is double, and the end time. So inside our initialize, let's use a guard. So guard, now we're going to make sure that end time minus start time is greater than 10. I'll add parentheses. So if it's not, then we'll return a nil. But if it is, then we will return, actually we'll just initialize struct. So we will do self dot start time is equal to start time, and then self dot end time is equal to end time. Now let's see what's happening. Okay. Now we have to leaf test this initializer. but I guess we're not testing it right yet. So imagine a screen where the user inputs a meal that they have eaten. The user taps the save button without adding any food. Might want the prompt to the user they haven't actually added anything. Using the food struct and text fields provided below, create a function called log food that takes no parameters and returns an optional food. So let's create a function called log food. It takes no parameters but returns an optional food. So it returns an optional food object, and inside the body of the function, use a guard statement to unwrap the text property of food text field and calories text field. So we'll use guard let, and let's call this food, and then that'll be equal to food property dot text. We'll do the same thing with calories, which will equal calories dot text. So else, so if they are nil, then we will return nil. Okay, let's see. Now, in addition to unwrapping calories text field, you'll need to create and unwrap a new variable that initializes an int from the calories text field. If any of this fails, return nil. After the guard statement, create and return a food object. Okay, so now let's use a if let, and we'll call this calories as int, and we'll set that equal to the int value of calories. So if it successfully converts it to an integer, then we can now create our food object, or we can store it as or calories of int. So if let calories of int will be equal to this, and I believe we're just duplicating it because it's the same thing that will happen. Now let's create, so else and nil. Now let's return our food object. So we're going to return food, and it takes in the name, which is our food that we stored here, and it takes an int, which is calories as int. Okay, so it seems that so since this is stored locally, this is actually not part of the scope, so we can use a guard for this too. So guard let and else, then we will return nil here. So we're going to remove our else statement here, and we'll return nil. Now this should be able to accurately return nil if one of these are nil, or if we can't convert it to an int. So should we call our log food function? I guess it's not necessary. And capture return. Okay, now we're doing. So we're going to unwrap the food object with standard optional binding and print the statement about food using each of its properties. So let's do if let, and we're going to create a food object. So we could call this food, and if that's equal to, I'm going to call log food. So if we return something, then we are going to print, wrap the food object with and print the statement about the food using each of its properties. So print, then let's say we'll do food dot name as, we'll do the number, so food dot calories. Banana has 23 calories. Now go back and change the text in calories text field the string that cannot be converted to a number. Okay, let's make that like that. What happens in that case? So let's print if we change to a string that cannot be converted to a number, then we get no output. Great, we have completed guard, and we'll see you in our next Swift lesson, which is about scope. Hello, in this video we'll be going over segues and navigational control in the Swift programming language. We'll also create a login app that passes in data from one screen to another. Let's get started. Let's first open Xcode. Now let's create a new Xcode project. Now make sure it's iOS and make sure it's an app. Click next. Now let's name this login app, and you could choose a organization identifier and make sure it's a storyboard and it's in Swift. Click next. Now that you've created your app, now let's go over to the main tab. So let's add another view controller. Click the plus icon and then type view controller. Now we have created our second view controller. I'll drag it. Now let's add two text fields. So to add a text field, we could go here, text field. Now let's drag it over to our, so this first one will be a login page. Let's drag it over here. And then let's go over and get another view controller. And now we'll add it right underneath. So the first one will be like the username, and the second one will be like the password. Now we'll add 3 buttons. So go over here, type button, and then we'll drag our buttons here. And we'll also add another button, and we'll put that over here a bit to the side. And we'll also add another button. And the reason for these additional 2 buttons at the bottom are like forgot password and forgot username. Let's actually move this a bit into the center. Now let's change the text of this button. So change the text of the button. We can go here, or we can so we can say login. So we can do login, and then for this button we can say forgot username. For this button we can change it up and say forgot password. Now I'm adding placeholder text. I'm saying username, and then over here I'm saying password. And so now it's starting to look like a login screen. We can obviously make these longer. Now we should hide the password when we type. So let's do secure text entry for the password text input. Now let's create a segue from our button to our view controller. So to create a show segue, just hold Control, and so hold Control and just drag it over here. Now it should be highlighted in that blue color. Now click on show. Okay. And one more thing, let's change the background to a different color, possibly system gray 3 or system gray 4. And now let's go over here and let's actually go over to a landing screen and choose the presentation option. So there's a presentation option in the attributes, and it should be fixed, or full screen. There, so presentation, full screen. Now let's run our app and see. One more thing, I'll change it to an iPhone 13 Pro. And let me go back to the main. Okay. Now let me run the app again. And so the reason we changed this to full view is because before it would just be like a card where you can swipe down and see the background, go back by swiping down to our login screen. But we want the user to feel like they entered the app. So this creates a more realistic version. Okay. So when we first open the app, we land here. So there's multiple ways to fix it. One way to fix it is by moving the objects from here to there. Another way is by setting this as the initial view controller, so this wouldn't be the initial view controller. So if we go here, click on this view controller, and go over here, it's the initial view controller. Or if we go over here, it's not. So if this is the initial view controller, when we first run the app, this should be the first thing that shows up. Great, and we added a segue, so when we click this, that pops up. Great. One thing we noticed is that we can make the button longer. So let's do that. Nice. Now let's add a navigation controller. So go plus icon and navigation controller. So here we have added the navigation controller, and we can actually remove the root controller. So this should lead us like this. And now let's add a title. So let's remove this title. So let's go over here, remove the title. Okay, or it's fine. We can actually keep the title, but let's make sure that this title is large title is set to always. So when you click, it should be large title. So let's find where that is. So right here, let's do prefers large titles. Now let's click on the navigation item here in our landing page. This navigation item. Let's change large titles to always. Now let's close this sidebar and let's open our assistant. And we can close this sidebar too for now. And we can, okay. So let's open our view controller. So let's go here and then view controller. And now let's add the prepare for method function. Now let's do at IB outlet. So what I did was I went over to the editor and then I clicked on this, went over to the editor, and then I clicked embed in a navigational controller. So now, since we embedded our navigation controller in here, let's open our assistant. And let's create an outlet. So hold control and oops, okay, let's close it out. Come here and then open our assistant. Hold control and drag. Let's hold this. And then we need to access. Okay. Let's try again. So now let's add an outlet for our text label, text input, and let's also add a Segues destination. So we're basically changing the title of our destination to of the text labels. Now let's run our app. Sorry, I had to cut some of the video due to receiving an error, but now it's fixed. So what I did was essentially I created a segue from each of these buttons to our landing page. And now if I open the assistant, now in the segue, we can, so I created as a function to prepare. So for that segue, when these buttons are clicked, there is a guard, so sender, so it makes sure that the sender is nothing but it's not null essentially. And then if it's from the forgot password button, then it sets the title over here to be forgot password, and if it's from forgot username respectively, sets the title to that respectively. And if it's from the login, then it sets it to username.text. Let's run our app and see how it works. And another thing, I created outlets for these buttons. So if I click here, it creates a title, forgot username. If I click here, forgot password. And if I say username, Don123, click login, it also puts that as a title. That's it for this video, and see you in our next lesson.
Hello, in this tutorial we'll cover how to build a project in Xcode and use Interface Builder to create a label, a button, and connect them using an action. So let's get started. First, let's open Xcode. And then when Xcode opens, click Create New Project. And make sure it's an iOS and New App. So basically, we first have to create a product name. So this is the name of our project. And I'll name this Interface Builder. And the organization identifier, we'll go with these into more detail, but the organization identifier is essentially something that comes before your product name, and both of those combined is your bundle identifier, which is a unique name assigned to your project. And the interface, make sure it's in Storyboard and language switch. So firstly, go over to the main in the left, and then we'll see our iPhone. And I will choose iPhone 13 Pro. And now we can start. So to add any elements to the screen, we need to click on the plus icon over here. And then first, let's add a label. So to add a label, you'll have to drag it over here. So a label essentially is like text. And you can double click on it to change. So you could say, this is my first app. Now you can easily drag it around and increase the width of it, width and height. Also, you can change the color and font using this panel on the left. And let me increase the width. And you can also change the color, background color of the screen. So I'll change it to system orange color. And I'll also increase the height. Okay, so this is using a label and changing the background color of your view. And now we can add a button. So this button, you can also change the text by clicking on it. So let's say press it. Let me also increase the width. And I'm going to center it. And now for this button, we can also change the color and change the color of the text. For now, I'll keep it default. And now to be able to link this using code, we would have to go over here and then click Assistant. So Assistant allowed us to easily use the storyboard and code it. So over here, click on, let me move this, and let me move this bit to the right. So we can close this by clicking here. And then, so to link your label, you would have to click Control, and then click on it, and then drag it over here. So if you put it over here outside the class view controller, it won't do anything, but if it's right underneath the class, it'll add a outlet. An outlet is essentially a way to connect the elements in your view. I'll name this label message. And now the outlet is created. And now we can also use our button and create action. So we'll do the same way by clicking Control and dragging it outside this time, still in the UI view controller class, but underneath the view did load function. And we'll name this button pressed. Now we can edit inside this function to be able to change the text of this label. So we'll take the name of the label, which is LBL message. Then we can use dot text equals to a string. So we'll name it button pressed. And now let's run our code and see what happens. And just again, so I'm in iPhone 13, and you can change it by clicking here. And the simulator opened. It takes some time to load, and you can also add a splash screen, so launch screen. But that'll be for a future video. Now let's test it by pressing the button, and see when we press the button, it changed the text to button pressed. That's it for this video, and we'll go into in depth in future videos.
Today, we will be making a game called Apple Pie using Swift and Xcode. It is a word-guessing game where a player has limited amount of tries. Each unsuccessful attempt will cause an apple to fall off, and the player wins the game if they can guess the word before all the apples fall off. Let's get started. Firstly, let's open Xcode. My Xcode version is 13 and I'm using Swift 5. Now, let's create a new Xcode project. Make sure it's in iOS and let's create a new app. Let's name our project Apple Pie. And make sure it's in Storyboard. Our project we're going to make is only suitable for an iPad due to it requiring a bigger touchscreen. So let's uncheck iPhone. Head over to the main Storyboard, and now let's change our device to an iPad. Let's also change our device here to an iPad. Now let's change our orientation to landscape. Now, to construct what we saw earlier, let's add a vertical stack view. Drag it over here. Now, let's add constraints. Head over to constraints, and since we want it to cover the whole screen, let's make it 0 for each. So that'll make our vertical stack view cover the entire screen. Add 4 constraints. Now we're ready to add views and controls. Head over to Object Library and then grab an image view. Since it's the only image, it'll take up the entire screen. Now, let's change the content mode to aspect fit. After you made sure it's an aspect fit, now we can add our images. We'll be adding these 7 trees to our assets folder. Now our 7 trees will be shown in our assets folder, and we can use these to access over here. So we can choose what image we want. One more thing, make sure your images are set to single scale. Head over to scales and choose single scale. Now we have to add the keyboard. Even though we're updating the images, let's choose one so it's easier to visualize. And now we have to add the keyboard, and to do that we can imagine it being a vertical stack in the vertical stack. So the keyboard will have around 3 items in the vertical stack, and then there'll also be horizontal stacks inside each vertical stack. Head over to Object Library and grab another vertical stack. Now click on your stack view, and then we'll change the alignment to center and distribution to fill equally. We'll also add spacing of 5. That illustrates the 5 pixels of spacing needed between each horizontal stack view. So let's head over and grab a horizontal stack view and drag it in our vertical stack view. Set the spacing to 5 and make sure the alignment and distribution are to fill. Now let's head over and grab a button for stack views. Each of the 3 rows will have a unique number of buttons in our keyboard. Let's drop our button inside our horizontal stack view, and we want our buttons to be square. So we have to change the aspect ratio. Let's change the aspect ratio by clicking here and then going over the constraints. Make sure that they're all 0, and then check the aspect ratio. Click Add Constraint. Now let's set the multiplier to 1. Now click on the button and make sure you change the font to System, and also make sure it's 30. Make sure the size is 30 so it's easier to read. Now let's copy our button, and then by using Command C, then doing Command V, so we have at least 10 buttons on our first row. Now make sure you change the letters to what they appear on normal keyboard. So capital W, E, R, T, and then Y, and then U, I, and we can add one more button. Drag it over here, and then we'll make that O, and then So this resembles our standard QWERTY keyboard. Now let's create our rest of the keyboard by copying our horizontal stack view. So now we have 3 rows. Now we can edit it to match our normal keyboard. So let's remove a few. We need 10 in this one, 9, and then 7 in the 3rd row. So in the 2nd row, we can remove 1, and then the 3rd one, we can remove 2. Remove 3, okay. Now we can easily change it by double clicking. So A, S, D, F, G, H, I, J, K, L, and for this one, or for the 3rd row, Z, X, C, V, E, N, and M. Now we have completed the keyboard. Now, within the 2nd stack view, so this one, let's add 2 more labels. So 1 label inside it, and let's make sure it's below all of our other stack views. Now we can drag it over to right below our 3rd one, so not inside, but right below it. Now let's copy it using Command C, and then paste it using Command V. Now, let's click on the 1st button, make sure it's centered. Same thing with the 2nd button. And let's change the font of this to 30. Now we'll center our 2nd button and change the font to 20. And now our layout is complete. So let's run our app to make sure everything's working. Make sure you have no errors or warning messages. One more thing. We need to set the correct priority or else our labels in the bottom might not show. Let's go over here and click on the error message. Let's click Change Priority. Now everything will use auto layout to resize. And I also changed my iPad to the iPad Pro 11-inch 3rd generation. Let's run our app and let's see how it looks. Let me rotate this. Great, everything looks as it should. And since we're using auto layout, it automatically adjusts the layout. Let's continue. Now let's start programming our layout. Let's open the assistant by going over here and clicking assistant. And now let's make some room so we can see our iPad. So that you should see a view controller function here. First, let's start by creating an outlet for our tree image. Click Control on your keyboard and drag it over to the code. And now let's create a collection for all our buttons. Hold the Q button with Control and drag it over here. Now, instead of an outlet, let's do outlet collection. The reason we're doing this is because it will be tedious to create an individual outlet for all of these buttons. Let's name this letter buttons. Now let's connect the rest of the buttons to the button outlet collection. Hold this circle here and then drag it to each of our buttons. So W, and then E, to the R, to T, to the Y, U, and so on. Now let's create an action for the button. Also again, it will be tedious to create an action for each of the buttons, so let's group them. Click Control and drag the Q over here. Now make sure it's let's drag our button here. Make sure it's an action. Let's name this letter button pressed. Let's also change the type of the argument to, we'll keep it as sender. Now let's click Connect. When the user presses a button, it should be disabled. To do that, let's do sender is enabled equals false. Now we'll need to change any to UI button. So changing it to UI button allows it to individually change the titles of each of our buttons. Now let's control drag each of our buttons to our function. So we'll control drag the W to our function, and it shall turn blue. Now let's do control drag E, and you'll know it's connected if it turns blue. Now let's connect our last button. And we're done. We connected all the buttons to this action. Now let's verify that tapping each button disables it. Let's build and run our app. So let's see. So we have to make sure that tapping each button disables the button, and that shows us that we have connected all of our buttons. Great. Let's head back over to Xcode. Now we're ready to start building the logic. At the top of View Controller, let's create a variable called bar or list of words. In this variable, we can now store our first set of words that the players have to guess. This will be a list or an array. Now below our list of words, let's create a constant called incorrect moves allowed. And this sets the number of attempts the user has to guess the correct word. Let's set it to 7. Now, we also need to set number of total wins and number of total losses. We will use this to print the total wins and losses for the user. Let's set them equal to 0. Now, let's create a new round. Right below the function view.didLoad, let's create a new one called new round. Now let's create a new Swift file to keep our game struct. We'll use that in our new round function. So click Command N and click Swift file. And we're going to name this game. Now inside of game, let's create a struct called game. This will define what a game is. It will have two properties, the word and incorrect moves remaining. Now let's head over back to our view controller. Now let's add the current game variable, and we'll set it to an instance of game. And we'll also have a new round function, a new variable, new constant called new world, and we'll remove the first word from our list so it changes each time. And we'll also create a new game instance called current game. You may wonder why there's an exclamation mark after the game. It's because for a brief instant when your app launches, the current game won't have a value. And for now we'll say that we're letting it know that it's okay for it not to have a value, but we'll cover null values in future sessions. Now we need to create this new update UI function. In our update UI function, we will essentially be changing the UI two main ways. First, changing the text of the score label so that it showcases number of total wins and total losses. We'll also be updating the image so that we change the image that is being shown with the number of apples. Now let's call our update UI function. Now let's run our app. It should showcase the beginning of a new round. Great. Now inside our letter press button function, we're going to set a new constant called letterString, and we'll set it equal to configuration.title. The reason for the exclamation mark is so that it knows that some buttons may not have a title. And then we'll also set letter to the character of the letter string. So we'll lowercase it so it's easier to compare with our list of words here, which all are in lowercase. Now, in our game struct, let's head over and add a few more things. Firstly, we need to add a guessed letters array. This keeps track of the letters they guessed. We also need to add a mutating function to be able to see if the letter they guessed is contained in the letter that they need to guess. And if it doesn't, then we subtract incorrect moves remaining by 1. Now let's head over to our view controller and change where we call our current game, because now it also needs the additional input, the parameter. Now we'll set guessed letters equal to an empty array. And here underneath our update UI, or underneath, actually over here. So now we need to add how we are calling the player guest function in current game, and we also need to update the UI every single time the button is pressed. Now let's run our app and see if it displays it correctly. So if we press something, it seems that we found a nil while implicitly unwrapping an optional value. The reason we ran into this error is because we forgot to initialize new round here. Let's run our function. Great, it can be seen that the number of apples are disappearing each time we press it. Now we need to create a computed computed property so that we can see what letters they entered and what letters is wrong. But to be able to do that, we can use a formatted word struct, and we have a formatted word variable, and inside our game function, we are creating a formatted word variable. Let's put this outside our mutating function inside our game struct. Now let's go over to our update UI function and add that. So let's see if we run it. The correct word label.text changes to the current game.formatted word, so we get our formatted word. So if we press a letter, we get our formatted letters here, like that. Great so far. But we see another error. 2 underscores together looks like it's fully underlined, so we don't know how many characters there are. We can add spaces, but it's just purely improving the aesthetic, but we're not actually changing the code. So to do that, we'll use we'll make our letters into an array, and then use a join separator, which separates everything with a space. So now this changes our corrected word.labels text. And we have also created a new variable called word with spacing. Now let's build our application to see a clear space between what we type, and let's go. So we have seen the different characters, and we also know how many there are. But we see 2 issues clearly. 1, there's no winning, and 2nd, there's no losing. So we don't know if the number of incorrect moves remaining falls below 0. So to do that, let's create a new function that handles this and checks the state of the game. And to do that, we create a new function called updateGameState, and it checks if the number of incorrect moves remaining is 0, then it increases loss. Else, if the correct word is equal to the game word, then you add to the wins. Else, you just update the UI and it continues. So now we have to implement updated game state into our let and button press, so it changes the game state every single time the button is pressed. So we can essentially remove update UI and put update game state, because in our update game state we also update the UI. Now it's really close, but every time we add to our losses or wins, a new round isn't starting. To do that, we can add a didSet property to our total wins and total losses variables. Here we can see every time the total wins is updated, we call new round. So we're getting an error that new round isn't in the scope. What we can do is move all of this over here into our UI controller. And now we can remove this from here. Now let's run our program and see. So let's finish this game. So I ran out all my guesses, and there's 1 loss. Now if we continue, I can keep looping, and then it adds 2 loss. But we run into an issue. When all of our letters are disabled, we don't have anything to re-enable that. Also, if we run out of letters in the list, the game crashes. So we have to check if the number of errors in the list is empty or not before we proceed. Let's fix these last few bugs. So inside our new round function, now let's add an if check that checks if number of words is empty or not. And if it's not,
then it just enables the letters, and if it is, then it restarts a new game. So we have to implement enables letter function. Let's do that now. And now we have create a function called enable letter buttons. This essentially just takes in the true or false. So this takes in whether we should enable them or not. So if we should enable them, then it just sets them to true. So every time for every button in our buttons, it makes them is enabled as true. Else if they shouldn't be enabled, it makes them all set to false. Now let's run our program and see. And if we test our app, it works like it should. And we have one win. Now it also enables all our buttons again so we can continue to play. This is great. And there might be a few other advanced features we could add to this app, but for now, that's the scope of this exercise. Thank you for completing this app with me, and looking forward to see you again in future Swift videos.